We're good. Everybody can see. All right. So I'm Matt King from NVIDIA. I'm a security architect at NVIDIA, and I'm here to talk today about secure manufacturing. I would like to give a shout out to my coworker Jeff, who was unable to make it today, who's been instrumental in putting all this together. He gave a talk in the Open Compute Security Work Group earlier this year about a similar topic, and this is kind of an extension of that. So going to start out sort of explaining what do we mean by secure manufacturing, what are the goals, and what is the environment that we need to do this secure manufacturing in. And then sort of provide an overview of who's trying to break it and why, what they're going after, what we're trying to protect, what our goals for protecting those assets are, and how, some preliminary thoughts on how that turns into functional requirements for manufacturing flows. Then we'll sort of conclude with a call to action. So what is the goal of secure manufacturing, right? We want to produce quality endorsements for device identities. There's an ever-increasing number of things becoming dependent on high-quality device identities in order to verify the security properties of the system, right? We're building Calyptra as a root of trust for identity. Why do you trust its identity, right? Where did that identity come from? How do you establish confidence in that identity that you are then building on top of? And so the way we do this, we have to build a framework in order to deliver these identities, right? You have to get Calyptra's identity right, otherwise everything you're building on top of it falls over. So when we're talking about provisioning, what are we specifically what we're doing, right? We're talking about things like unique identifiers, in DICE terms, a UDS, private and public keys, right? If you are injecting keys directly into the device, certificates associated with those keys, secure configuration that is ensuring that the device is operating in a secure manner, which you probably need to do after you're done testing for manufacturing. And also, how do you know all of these provisioning steps have been done correctly, right? You actually have to check your work after manufacturing to make sure it comes out right, instead of just assuming that your manufacturing flow worked. And we need to do all this because, at the end of the day, we need something auditable and verifiable coming out to prove that this identity is trustworthy. It's great to say our manufacturing is secure. It's less great to have no evidence of that effect. And so we really want to get to the point where there's some common guidance on how to go about this, and mostly what customers expect, right? Like, what is, when I'm trying to sell a device that I say has a secure identity, what is going to make customers believe that I've actually done that provisioning correctly? So the ecosystem for secure provisioning, it's got a few goals, right? It needs to establish unique device identities. We need to be able to differentiate device A from device B, vendor A from vendor B. We need to produce authentic endorsement requests for certification or something similar, right? We need to know that after we've assigned this device unique identity, we need to be able to somehow prove that in operation. And then we need to be able to bind those identities from the thing issuing them, right, certifying them to the device. So, one of the reasons this is difficult is most of the time we assume data transmitted between the device and the provisioning service is going over untrusted intermediaries. We don't really want to put faith in the security of the systems between the device we are trying to assign an identity and the service saying, like, this is indeed verily a good device. And that's because there's just a lot of things there. There's test equipment, there's networks, there's a lot of operators. Many of these things could belong to contract manufacturers. And whether or not it's actually secure to an acceptable level, it's incredibly difficult to prove that it is secure to that acceptable level. And at the end of the day, what we're going for is evidence we can use to convince people that this has been done correctly. And it's very, very hard to prove that your ATE appliance was secure at the time it provisioned a device. And so cryptographic controls that can be audited and produce evidence trails are a lot more useful than other compensating controls that may provide the same level of security but are a lot more difficult to attest. And the reality is, like, even if you have those other compensating controls, how good are they, right? Test equipment is often running old, outdated software and operating systems, running old drivers. It's probably not getting patched. There's often, anybody who's dealt with OT environments has seen uncountable issues in those network infrastructures. It is really difficult to secure that middle part, right? It's a lot easier when you start taking things out and saying the only things we need to actually prove were secure were the provisioning service and the device it was talking to. And so we really want to move in the direction of being able to exclude as much of this as we can, because it's too hard to provide evidence that it was done. Whether or not it was done correctly, it's almost impossible to prove. So who are the attackers going after these manufacturing environments, right? Is this really a problem that we have to worry about? Are these attackers real, right? There's a lot of different reasons why attackers might go after your manufacturing environment, right? They might just be trying to clone your devices so that they can sell theirs as if they're yours. They might be, the classic boogeyman is they're going to go alter your devices so that when they get installed at the customer site, they're malicious and under attacker control. But much more often we see the economic attacks where you're impersonating or cloning devices. They may also want to steal your IP. They may be attacking the manufacturing not to go after any specific devices or users, but to just get at data that you didn't want other people to have. The problem is when we're talking about manufacturing, it is a long, slow process. It happens over very long periods of time. So the attackers have a lot of time, right? If somebody's serious about going after your manufacturing, they've got a lot of time to do it. And because they have a lot of time, we also give them a lot of credit for they're going to have a lot of capability because they're going to have the time to go attack your systems. They're going to have the time to, compromise associated things and learn about your devices, reverse engineer them, and figure out how they can do it. So we really don't want to rely on, oh, this is complicated or it's not documented as a defense, because it's complicated and it's not well documented, but you're manufacturing devices. And if you can do it, then the attacker with enough time is going to be able to figure it out. So we don't want to dismiss attacks just because it's harder, it's complicated. So what are the things we're trying to protect here? If we're trying to certify a device, what do we actually care about on these two ends of the provisioning service and the device? We have certificate authority keys. We have the device identity information, such as serial number and UDS. There's other secrets being issued to device, think HTTP keys. There's security-related configuration data, such as like turning off debug once you no longer need it. And then there's the signing requests and the logs of all the devices being generated. And not all of these are things that are necessarily secrets, but we do want to make sure that they're not being altered at the time they're happening. We want all of this data to be collected and to be accurate and to know when we go back and inspect our logs later that they are correctly capturing what happened. So on the provisioning service side, right, it's fairly straightforward, and it's going to be something that looks a lot like a traditional CA, right? So you don't want to leak the private keys. You want to protect, secrets being transferred between your provisioning service and the device. You don't want to accidentally send them to the wrong device. You want to make sure you're only communicating those secrets to an intended device. You don't want to issue identity. You don't want to certify the identity of somebody else's device. And you need to support validating and invalidating and recovering the certificate. So if you are issuing an identity to a device in the form of a certificate, you've got to have some way to manage. You're now issuing certificates. You have to manage, I think in the last talk we hit on, you have to manage your certificates. And you have to be able to provide information that the customers are going to need to verify this device you've issued an identity to. So that at the end of the day, you've provisioned the device, now you have to provide the customer something, generally in the form of a cert chain, so that they can verify that, yes, this device was authentic. For the device, it's a similar set of requirements. You have to make sure that you are only accepting things from the intended provisioning service. You don't want to send your device out and have it be provisioned by somebody else's provisioning service. That leads to a lot of interesting attacks and confusion about whether this is a legitimate device or not. Again, you have to protect the information going back and forth between them. And the device has to be very careful that it's not leaking secrets, right? Either during provisioning or after provisioning. And this ends up often being difficult because provisioning is happening in manufacturing at times when devices may not be as protected as they are in production environments. And the last thing the device has to do is it has to be able to prove that this happened correctly, right? The device needs to be able to respond to some challenge to be sure, so the provisioning service can verify that everything the provisioning service intended to stick into this device actually took, right? You don't want to try and provision a device identity only for the device to drop it on the floor, and maybe it gets put into a different device later, and now you've got a device that's not in the state you expected. You really do need to go back and verify that all of this happened correctly, because otherwise, if and when something does happen, if there's God forbid, there's an incident later, once devices are in production, you really are going to need that information to come back and see what happened and understand whether that really was a legitimate device or something else. So this is where we are now, right? We've started sort of writing down what we think are likely functional requirements for devices and for the provisioning service that are necessary in order to make a process like this work. These are not set in stone. This is where, in a minute, I'm going to ask for help, right? But you end up with things like the provisioning service has to encrypt confidential data. It's sending to the DUT using unique keys, right? It can't reuse session keys between different devices being provisioned, right? And then the DUT has a corresponding requirement, right? Both sides have to verify the authenticity and integrity of data they received, right? Not everything needs to be confidential, but we do need to know both ends of this communication need to know who the other side is and that the data is coming across as intended, not being modified along the way. We need to know that the device being provisioned is a member of the intended device class, right? We don't want to accidentally provision device A with an identity intended for device B, right? Even if we're not being attacked, we don't want those mistakes to be possible. Similarly, the device should know it's being provisioned by the vendor that made it and not by somebody else. We want to confirm. We want to confirm that the DUT is what we think it is, right? So when it says class level measurement here, that's really, is this a legitimate device in the right state? You want to make sure this is a device ready to be provisioned. If there's firmware involved in the provisioning, that it's running the right firmware. We need to be able to revoke certificates. We need to be able to provide audit logs of what's happened, both so that customers can verify and so we can trace back after the fact. So in conclusion, right, device identity is becoming ubiquitous in the industry. It's getting used a lot. And that is all underpinned by the provisioning and certification of these identities. We really can't use them if we don't trust the identities in the first place. Manufacturing has a lot of attack surfaces that can make that reliable identity provisioning difficult and maybe not something you can just presume to be trustworthy. And there are a lot of potential attacks that could result in situations you didn't want and that result in the reliability of your devices not being where it should be. So we need to have meaningful and trustworthy provisioning, and we need the assurance about the integrity and the quality of what's happening at provisioning. And we're going to have to build up the ecosystem to do this because it is not straightforward how to do it today, and most of the solutions are very bespoke. And that becomes a problem when you're trying to manufacture things at scale, potentially in a lot of different places with a lot of different parties involved. So the call to action, really, we would like for there to be some kind of guidance from Open Compute on what is necessary and what is recommended for how to do this. It doesn't necessarily have to be a rigid spec, but there has to be some measure of what is acceptable and what is not acceptable, general guidelines, and goals for how to do this so that when people consume devices, they are confident that they are correct. So whether that's cryptographic algorithms or requirements on securing a provisioning service, HSM, or requirements for what the device has to present in order to prove that its identity is correct in the first place. So we're looking for help and guidance. There's a link to the Open Compute Security Work Group. Please come participate.
Thank you. That was a good presentation. One question I had is, when you're starting to cut out that test environment, as far as out of the trust boundary, could there be an extension of requirements to being able to re-provision a device in the field, possibly?
If you are able to successfully push everything between your CA and the device out of the trust boundary, then in theory, yes, you could re-provision in the field. In practice, I think that's really hard to get that far. I think there's going to be little bits and pieces that you're going to have trouble once you open it up to the entire internet instead of sort of a more restricted environment.
When the provisioning service wants to evaluate an attestation from the DUT, is the thinking that really it's going to be relying on class secrets at that point because we haven't reached the point where it has an asymmetric identity?
Yeah, you're going to have to start. A class secret's the best you can start with, because you're not going to this is the injecting the unique identity. So really, at this point, and the thing to keep in mind is before we have the unique identity, before we've provisioned it, all we're really concerned about is class membership. We just want to know this is a legitimate device that we should be provisioning. We don't really care about the distinctions between which device at that point.
First off, thank you for a great talk. This is desperately needed. I just wanted to say, first of all, that I'm going to respond to this call to action and I'm going to participate, so thank you for that. I wanted to ask a question about the other side of this equation, which you didn't talk about too much, which is how the endorsements are actually communicated to the broad number of people who are going to consume these endorsements. There's a couple sort of unique challenges there regarding the event streams that come out of the endorser. I noticed you talk about revocation of certificates, for example, which is a very sort of binary problem, but there's actually other types of events that we may want to capture as well on this endorsement. Things like, we don't know if the chip has been compromised, but the chip was apparently stolen, so something malicious may be happening to this device, but do we revoke in that case, right? There's actually degrees of this that aren't necessarily just binary. Have you given any thought to how we establish standards for protocols on the public side of the endorser?
To be honest, no.
Can I help with that?
Yeah, please.
Okay, thank you.
So also, have you put any requirements in related to RMA, when the part is returned back to the factory, if you would ever want to re-provision? Should there be requirements related to that?
I think it's going to be really hard to provide generic requirements there because what happens at RMA is going to end up being really device specific, right? If your RMA is blow away the device identity and then reprovision it, well, then you're just doing all this twice instead of once. If you have some other process, then maybe there's a different set of requirements you have to follow. I think it's going to be really hard to do more than provide high-level guidance like RMA must not expose the device secrets or something along those lines.
Thank you. Question on whether or not the scope could include cases where the device might have technology doesn't require that the identity and the keys be provisioned. Maybe the device self-provisions from intrinsic data on the device, intrinsic differences on the device.
So when you say self-provision, how do I know that it's an authentic device after it's right? You can self-generate data and an identity. How do I know as a user that that's an authentic device?
For example, SRAM Puff, where you basically will have a fingerprint that it can actually advertise and have validated back,
Right, but who says I can build a device with a puff and give you a fingerprint? How do you know that the device that you're querying is mine instead of yours?
Data that gets pushed with the fingerprint, then you can actually say and basically create an endorsement mechanism on the other side. Couldn't you?
I think you still have to have something pushing there's got to be some identifier saying this is in fact a proper member of the class. The problem is you don't want to use class identities very much, right? You definitely don't want to use class identities at runtime because class secrets don't last long. It's not a very strong mechanism because every device has to know the same thing.
I think there's some concepts to consider, so we'll probably respond.
Yeah.
Thank you.
All right, I think I'm about out of time.
Awesome. Thank you very much.
Yep.